Power plants are going virtual. For our listeners, a virtual power plant should sound familiar, and they are quickly becoming reality across the industry. What is a virtual power plant, or VPP, and what role does the utility serve in this entirely new frontier? We will talk about this and a whole lot more with our next guest on Energy Central's Power Perspectives podcast. Matt, a virtual power plant includes innovation, technology, and distributed generation. Share with us what you are seeing about VPPs from the Energy Central community.
Sure, Jason. And VPPs, they're no doubt at front of the mind for the typical Energy Central community members when it comes to energy innovation, combining advanced technology with distributed generation to transform the energy landscape. And the VPP excitement particularly surrounds their use of sophisticated software platforms, things like AI, to manage and optimize distributed energy resources from solar panels to battery storage to EVs. And so utility professionals in the community, they're fascinated to lean into that scalability, the flexibility that VPPs bring, and they can rapidly adapt to changing grid conditions, support renewable integration. So there's a lot of excitement in the community about it. But that said, there's definitely some key questions that remain for them. Things like the regulatory frameworks, the cybersecurity, and the economic models needed to make VPPs financially viable. So I think today's conversation will be very useful to that excitement in the Energy Central community.
Thanks, Matt. We're going to hear from a leader in VPPs who is moving beyond the pilot stage into utility scale operations. We're excited to welcome today's guest to the episode, Vicken Kasarjian, Chief Operating Officer at MCE. Vicken, welcome to the Energy Central Power Perspectives podcast.
Thank you.
Well, we're thrilled to have you here. So please start by telling us about MCE. Who are you and what are you all about?
Sure. So MCE, we're a community choice aggregator in the Bay Area. We are over Contra Costa, Marin, Napa, and Solana counties in the California Bay Area region. And our vision is to go to a world where we have eliminated fossil fuel, greenhouse gas emitting resources. And we have about 585,000 customers, about 1.5 million residents in those 4 county areas. And, just the way we are accelerating our GHG-free, fossil fuel-free resources, we have reached 95% greenhouse gas-free portfolio about 17 years before the state's energy goals, that is for 2045. So that's our summary, and I would love to chat about this subject a little bit more.
Yeah, absolutely. And we brought you in to talk about VPP. So let's dive into that. You know, our audience of Energy Central professionals are from the industry, so they understand it. I'm sure many of them are familiar with VPPs, and perhaps some of their utilities are participating in pilots in one form or another. But let's level set here for a moment. How about a brief explanation of what VPPs are and why now is an important time for MCE and other energy stakeholders to be leaning into them?
Sure. Really great subject matter. So VPP, a virtual power plant, is where through technology, we are connecting the energy resources that is in a particular location, a home, a business, a factory, where through technology, we want to connect the solar panels, the EV chargers, the smart thermostats, electric water heaters, and other devices that use electricity into a program to aggregate the total use at that meter location. So as people are living their lives, as factories are working, so the intent is to optimize at this physical location on how to connect several facilities like this and create the virtual power plant. So, and we'll dive into a little bit more on this, is that the ultimately is to create, given this new way of doing things, about how do we provide flexible power supply and support the grid on the high voltage level, even on the distribution level, on how to optimize the usage of energy. And all this is driving us towards a renewable zero carbon future in California by 2045.
Great. So let's dive into what MCE is doing. So you, as I understand, you have a VPP pilot. Share with us how far along are you? What is setting this project apart from the earlier implementations of VPP, both at MCE and perhaps elsewhere you've seen across? Talk to us about where you are in the VPP world.
Sure, absolutely. So this pilot that we have started in one of the most impacted communities in the Bay Area, it's in the city of Richmond. The beauty of this start for our Richmond VPP is that we begin by taking almost 100-year-old dilapidated locations like previous dwellings, homes, and we upgrade them to an all-electric, efficient, energy-efficient home. We completely retrofit it, and through special financing and support by programs, we make it available to a low-income folks that probably never dreamed about even buying a house, or having a home, being a homeowner. So this is where we begin for our virtual power plant, which 110% puts us at a different level from any other VPPs. So we actually start with a dwelling. We convert it to a 21st century home with all the smart appliances, and we refurbish it into a residence, and we are working on doing the same for commercial and industrial customers also.
That's really interesting. The thing is, though, I remember studying VPPs when I was a student. This was about 4 or 5 years ago. But VPPs even then and where they are today has evolved and matured. And yet you're still in pilot mode. So let's talk about this, because I feel like my understanding is that you want to change the behavior of VPPs and look at it more as like how we look at a physical power plant. That there are certain challenges that we need to overcome, certain ways of looking at a power plant and a virtual one. So maybe you could just talk a bit about what you've seen over time, and maybe remind us how long their pilots have been running, but how has that matured over time, and how has the general public viewed power plants, say, 5 years ago than compared to where we are today?
Absolutely. Great question. So I want to begin with stating that almost 15 years ago, the state of California investor-owned utilities world spent about $8 billion to upgrade the customers' meters from mechanical meters to real-time meters, smart meters. And the intent was to produce much more, correct data, information, and information sharing. Having said that, the virtual power plant, by definition, we're trying to make it act like an actual, real physical power plant, needs to participate in the market, in the California ISO market, react to system conditions. But if we rely on the meter itself about how the customer is using the energy at their site, well, that data comes to us in about, more than a day later after its usage, for that day's usage. So as far as the first challenge was to basically develop and design a technology-based metering system, a home area network system that will have access through Wi-Fi or cellular telephone setup, data information sharing, where every single element that is smart to be used at a location can communicate with this home area network. And from that home area network, send that information to our central processing center to optimize all the participating locations inside this virtual power plant now. And then after that aggregation, look at what the system is doing, primarily California ISO system that has about 80% control of the California's grid, and see how does our virtual power plant can actually participate in a bidirectional format. When I say bidirectional, that means it can inject power into the grid, or if the market is differently shaped, where we have, for example, right now with a lot of solar, We are enjoying almost 100% green energy in the state of California. Loads are low, sun is shining, and almost 100% of load is served by green energy. But having said that, prices, when the sun comes up, a lot of times is negative. So this virtual power plant, he should be able to, or will be able to, put a bid with the California ISO through this home area network system that is aggregating all the usages, and put a schedule with the California ISO that says it is ready to take energy from the California ISO. And since that energy is priced negative, right now in California, it's 11:17 a.m., and the prices are negative. So basically, we can help our customers charge their cars, charge their battery systems at their locations, and get paid for it because the energy prices are negative. So the data side is a big challenge. After that, it comes in the buy-in, the actual usage of this system from our customers, residential or business, large or small, about how satisfied or how comfortable would the customer be to actually participate in this controlled system of their location. So explanation of what our VPP is, how we are going to use this energy. For example, a customer that has electric water heater, we got to make sure that they never run out of hot water, no matter what we do with the electric water heater. Or if it's a hot day, that their AC can still run. Or do they have enough charge in their battery system? Do they have enough charge in their electric vehicle? So we are continuous discussion with these, and we're also talking about with our customers about how they can actually start with, let's say, from all the way the most basic way of energy efficiency, all the way to, let's say, on behavior changes when they should use power, electricity, or more of allowing us to, with a partnership with our customer, have more controllable devices, controllable systems that we can actually bid into the California ISO and take market benefits and share it with our customers. The last challenge I want to talk about, which is becoming a pretty serious one lately, it is how long does it take to interconnect a household, a business, or a consumer to the grid with all these changes when we are eliminating, let's say, gas pipelines, we are moving it to a higher amperage meter setup for our customer. The interconnection process is taking way too long. Like, for example, adding a battery storage system to a household, one of our customers, they had to endure 660 days of waiting to be interconnected. And we have some other nightmarish scenarios too, but that is something that we are trying to work with our League of Cities, with our regulators and the legislatures to see how do we accelerate the interconnection process as we are moving into 100% electrification. Well, there will be higher levels of usages. So that is another big challenge. The last thing I want to mention is that, or I want to emphasize that this virtual power plant that we are working on for MCE, it's actually the way I'm planning it, designing it, putting the use cases in place is to make sure that this virtual power plant actually acts like a real power plant. So that at any given time, we have locational information about what meter did what. We will have magnitude of capacity and energy that we are harnessing from our customers. After we use that information to bid into the California ISO scheduling system, and then we settle with the California ISO just like a regular power plant.
Thank you for taking the time to unpack that. I think it's really important. And I'm glad you called out the interconnection challenges. It remains a daunting issue and something that I had not necessarily calculated into the thinking process with VPPs, but absolutely you also have to have a interconnection. So it makes complete sense. It's a nationwide conundrum that all utilities are facing. How to expedite and accelerate the applications that are in queue to get those interconnections done. Vicken, I want to ask you about the topic. You mentioned participation a few times, and you talked about all the customers, the stakeholders we're talking about. Could be the operators, could be the end customer, it's the residential owner, the battery owner, so on. So there's a lot of customers here. It's a lot of participants. And we know that there's always going to be a population of participants or population of people that may not be able to participate. So my question is around equitable. How do you ensure that this remains an equitable opportunity for people in your service area? And what should people even, listening in their own jurisdiction bring back to be mindful of what it means to be VPP's equitable part of the, conversation and planning process? Can you talk about that?
Absolutely. Great question. First of all, I want to begin by saying that, the VPP that we started in the Richmond area is one of the most environmentally impacted communities in the Bay Area. There are, for a long, long time, there are many refineries in the area. There's a lot of asthma conditions, unemployed or underemployed and things of that sort. So we take these things very seriously, and we want to really make a positive change in the environment and in people's lives, in the quality of their lives. And based on our lessons learned about how we are approaching these things, we want to expand this into all of our footprint. So we are really trying to revitalize communities. Like I mentioned a little bit before, we're taking really dilapidated structures into making them a 21st century all electric homes and giving them opportunity to folks to become homeowners. We're subsidizing the price of the home is subsidized by some significant margins, even though depending on where you are in the States, Bay Area in general is very expensive. So even a environmentally impacted low-income community in general, that will have a pretty high number. So we're really trying to reduce those numbers and making them available to folks, like I said before, never even dreamed about buying a home. So to address the issue about the different customers and what we are offering, there is absolutely no mandate about thou shall from any customer. The burden of proof is upon us to show the customers what they can do. So we have many, many programs that we help our customers to improve their location's energy usage. And we have a lot of programs in helping them save money. They can come up, subscribe to some programs that they get, a monthly bill credit. And we give them advice about when the expensive energy is so that we don't use those times. They use it cheaper areas. We have app-based applications for energy charging for folks that own electric vehicles, about how we move them to areas time of use that it's a low charge. And all this will help us have a healthier grid, because at the end of the day, while VPP may have participants that would voluntarily participate in the controllable section of a VPP, when everybody participates, from energy efficiency to change in habit, change in usage patterns, all the way to dispatchability of the system, all customers will benefit, because at the end of the day, MCE will also benefit by not needing to purchase in times of very expensive power needs in the system. So everybody will benefit when we can reduce our costs also. We are primarily, the fundamental footing is to help the community we are involved in an equitable way, to improve their quality of life, to give them something they never thought before. And then as far as what do they participate in, it's going to be from almost nothing, from energy efficiency programs, change in habit, usages, all the way to dispatchable resources if they volunteer to. And the area that we're going to need to do quite a bit of work in this dispatchability of the asset, which is the highest value, we need to come up with ways to be able to clearly and precisely to explain to our customer, for their own choosing, how are we going to basically share the benefits? Because we can work with aggregators, we can work with our customers in our footprint, we can work with business partners, and how are we going to think about splitting or sharing the benefits of the whole thing with our customers?
Yeah, I think you captured it. Those are all fine points. But now let's narrow it down to the specific participants and your recruitment effort. I'd love to hear from you. And as I mentioned right before we jumped on the recording session, I turned my air conditioner on, and I wasn't familiar with the loud noises that the AC makes. So let's talk about actual customers. We're talking about people who are going to, they're the load, they're the demand side of the energy. So what's it been like? You must have some skeptics. You may have some early adopters, but what's the general experience been like for those that are participating, or as you're approaching and trying to get recruiting to participate in a VPP? What can you share with us what that experience is like?
Absolutely. So there are always the skeptics and early adopters, but it is the burden of proof is on us to show what can be done and how it can be done. So in addition to explaining to the customers how all these parameters would work, we look at our individual specific customers that have very high usages, and we try to find out, why. For example, are they capable of moving their usage time to other times where the energy or the capacity cost is a lot less? So we interact with them and we try to explain to them, but what's going on in the market. The other area is, in our footprint, we have more than 85,000 rooftop solar customers. Altogether, there are, 500-600 megawatts of capacity out there. But, with a lot of the surplus solar panels in the system, when there is so much surplus, when the sun is shining, we try to find out from these customers, do they know about the opportunity of adding storage at their facility or multi-apartment dwelling or multi-residential dwelling or businesses that can actually save quite more if they have the storage at their site? If we have some low-income folks, we have 0% financing to do these things. We provide 0% financing for them to upgrade their energy panels with the utility. And we work with our customers, larger customers, to see what do we see for them in optimizing their resources. As EVs, for example, have grown in popularity and there are surpluses in the system, the latest proposals are that an exporting location, a customer that has solar panels that their load is so low that there is excess being exported to the distribution system, the value of that export it has been diminished significantly. So, for example, recently we have been talking with businesses and residential or any customers in our footprint to explain to them the value of having storage on site, or even electric vehicle, electrification of fleets, about how they can optimize the usage of their solar panels. So we spend a lot of time in analyzing the usage patterns of the customer. We explain to them what does that mean. And they do not need to participate in controllable devices. Like I said, we try to build them into using it smartly, where the value, if they can shift their usage time, like the air conditioning, for example, there are times when it is hot, it's hot. You need to turn it on, right? The air conditioning. But if you can delay it for some time, or if you have a battery that is charged by solar, that you have green energy on site, and how you can complement that, we explain all these things.
I'd love to ask you about now sort of the infrastructure of the grid in your jurisdiction. As let's put it this way, every utility is going through its own transformation and modernization. And in your case, you're adding a layer of interesting assets that are not necessarily owned by the utility, but it's introducing a whole new paradigm to the utilities generation mix and how you operate the circuits at the local level. So the question is really along lines of, how does the challenge of VPP implementation rise as more demand gets added to the grid? And on the other hand, what are those opportunities that will either present themselves or you think are going to present themselves as this continues to grow? And I'm saying this in the context of the rise of EVs, the electrification of homes, the electrification of buildings. It's just become so much more demand on the grid. How are you supporting that? And then now you're adding VPPs to it. Talk to us about that.
Absolutely. Well, I think the VPPs are a must-have for the future, and let me explain why. The United States is split into regional transmission areas in the Western system, which is west of Mississippi, that goes from Canada to Mexico, is called Western Energy Coordinating Council. The total system of that footprint is a very large number, more than 160,000 megawatts. California is about 55,000 megawatts, the portion that is inside California ISO. If you add LADWP and a couple other balancing authorities that we have, it's about 65,000 in peak summer conditions. When we completely electrify California and we eliminate all gas, that load will become almost 3 times as much, equaling the whole Western United States system. We will go from about 60,000 to 160,000. So the paradigm that we are going into, the way I see it, is that the high voltage grid that will require dozens of super high voltage transmission system that needs to be added in California, it needs to have a partner from the distribution system that with all these variable load centers, with all of our customers that have the minimum, the solar, the battery, and an EV in their locations, the distribution system that used to be grid to distribution, a one-way highway, one-way traffic that goes from high voltage lattice towers, transmission lines to poles in our streets. It used to be one way. Now we are going into a world that is bidirectional. The distribution system is becoming a resource to the grid, and the VPP is the single most effective, impactful resource for this future. So that we need to make sure that we are not overburdening the grid by overbuilding, and yet the grid needs to take into account what is distribution doing. So while we are electrifying, we're adding a lot of load on the loads, a lot of energy usage and energy capacity shifting resources on the distribution side. The distribution needs to be able to, quote unquote, talk effectively in real time with the grid, so that the grid operator does not do something they don't need to do, does not order construction of power plants, does not order of construction of additional transmission lines to serve that load. If we don't do that, it will be really hard not to see half a dozen to a dozen of very high voltage lattice tower transmission lines almost anywhere you stand in California in the future. Probably it will be ugly. But if we do this optimization where the grid and the distribution system talk with each other, it will be the most ultimate outcome, the most efficient and the least costly, while we're offering equitable and healthy future for our customers.
Okay, Vicken, I want to, if I may, I want to challenge you on that. So you're saying that with VPP, we could reduce our need for potential new transmission. Did I understand that? Is that one of the potential outputs?
Yes. Yes.
Okay, and then you're also suggesting that through VPP, we could possibly or potentially avoid certain distribution operator upgrades as well? Yes.
May I expand on that a little bit?
Yeah, please. No, please.
Sure. Like, for example, in the so-called old days, there would be, let's say, a new housing area being built or no mall being built. The transmission provider comes in and adds the poles, the distribution system to serve that load. They build a substation, they buy transformers, they go, the load is going to be this much. Well, they never, ever thought about, well, what if this load that we are adding can actually become a generator that is reversing the power flow, or by itself, reducing the load consumption of itself. So it will be crucially needed communication between the transmission, the distribution provider, and the entity that is representing load, which is like entities like us, like MCE, to inform the transmission and distribution provider that, I have so many solar rooftops, I have so many batteries, I have so many electric vehicles that can charge at the right time and they can discharge at the right time. So the peak usage can be reduced. The size of equipment can be reduced. The behavior changes will impact the usage patterns and the total consumption. Because imagine when every single meter is actually a little bit of a generator that in the so-called olden days was never thought about. But this is becoming more and more, and with the advancement in technology and artificial intelligence, the modeling systems, there has to be a direct link all the way to real-time operations. I'm not just talking about planning. To build something is planning, long-term planning, short-term planning, but actual day-to-day operations, hour-to-hour operations, even real-time operations, which the California ISO has every 15 minutes. There can be a really nice, solid connection between the distribution, which historically used to be considered as load, and the future, where the entities on the distribution system can be a load, it can be also a generator, and everything in between. I hope that was helpful.
Yeah, I think it's very interesting. And it's not so much theoretical and academic anymore because of the pilots, including your Richmond pilot you're running. So let's talk about that. What is the timeline and outlook for that project? And how do you hope that project will inform and lead to additional such projects? In other words, how do you scale such a project like the Richmond pilot that you're running?
Yes, we took an opportunity with some partners for an Energy Commission grant for the development of this VPP, actual physical scheduling with the California ISO, bidirectionally, settlement with the California ISO, and seeing the actual workings of these home area networks and the dispatch and non-dispatch models altogether. And that is supposed to end by the end of next year. We learned a lot. We're gaining a lot of experience and momentum in this. And we recently at MCE, we decided on a 10-year vision for our future. And that 10-year vision is a vision of implementing a virtual power plant across our footprint. There is a lot of communities that are interested in knowing what we do, how are we doing, what are the benefits, what are the costs, what are the risks, what are the areas where we need to do maybe more convincing. And we are open to all inputs on how we do expand this in an equitable way. We are, for example, really emphasizing how do we continue improving people's lives in an equitable way. So we are already working on how we will expand across our footprint. We're looking forward in wrapping up this project by the end of next year and seeing where we go. We're looking at, from municipal entities to apartment complexes to folks that have existing solar and battery at their locations on how to optimize them. And we're going to use that all for our VPP future across our footprint.
Right. And I understand that VPPs is not the only innovation that you're running. In our lead up to the show, you had mentioned other advancements and initiatives under MCE. Would you like to talk about that?
Sure. So at a very high level, like I mentioned, we strive to a greenhouse gas-free energy for the future. And we accomplished that last year at 95% greenhouse gas-free, almost like 20 years earlier than is due for the state of California. So we have so far in our existence, in our footprint, we have almost reinvested in our communities almost $250 million since we launched. We are also working on providing a new energy product where every single hour of every single day, the product of that energy is greenhouse gas free. So we are dabbling on that. And we have saved so far almost $50 million in supporting our customers that have the most burden by energy costs, because energy costs has come up. Now, when I say energy costs, I really mean that we can only control the cost of energy in our footprint The transmission and distribution costs are from Pacific Gas and Electric, which have gone up significantly lately. So we look at that and we really try to minimize the cost, especially on the most needy. But those are some of the big items we continue to work on.
That's great. I feel like I could ask you a million more questions about everything you just said, but at this point, which is a good sign, right? But
Sure.
At this point, Vicky, we really appreciate what you're sharing, and we want to give you the last word, but we want to pivot now to what we call our lightning round, which gives us an opportunity to learn a little bit more about you, the person, rather than you, the professional. We'll throw a bunch of questions at you. We ask you to respond with one word or phrase. So are you ready?
Okay, I'm bracing myself.
Okay, these are easy. What's your comfort meal?
Comfort meal, it's a lasagna.
Where's a bucket list travel destination that you'd like to visit?
Antarctica.
Do you have any hidden talents or perhaps surprising hobbies or interests?
Oh, okay. Well, I race. I race cars and motorcycles. I love racing. So that's my number one interest out there.
Okay. We're collecting lightning round questions from past podcast guests to ask future guests. So this one comes from our past guest, Rob Gramlich, and it seems well suited to you. So here's the question he's asking. The future energy system will see us needing to move tens of gigawatts of power across large swaths of the country. What do you think is the key to accomplishing this?
Data. I would say it's data. The customer needs to be able to see real-time usage data in real time, and they need to be able to see when, like you were saying, or Jason was saying, to turn on your air conditioning, or you want to turn on an electrical device for the next hour, the customer needs to see the financial impact of that decision they are planning to make before they make it. And the technology is there to make that happen. We just need the regulation to make sure that that happens. We will build way too much to just rely on existing system.
Okay, now it's your turn. What lightning round question related to energy or off the wall do you want to challenge a future guest to answer?
Oh boy. I think I want to go back to something I just said. The future guest needs to say about, the future where it needs to be. I would challenge them, but how would they see that happen? The availability of data for all of our customers, while it is protected by cybersecurity and artificial intelligence, how can that happen?
Okay. And lastly, what are you most passionate about?
I love to mentor, teach, and coach folks that are just graduating from high school or college about how to take on life. I'm an immigrant long time ago from Lebanon. I did not even know English when we immigrated to the United States in 1979. And I had a mentor that helped me a lot, guided me from ups and downs and challenges. I do that as often as I can with the young folks that are joining life. That's my biggest passion.
That's great. It's a beautiful story. That was fantastic to hear. And like I said, we're going to give you the final word. So looking forward to what VPPs can accomplish for our modernized power sector. What is the final message or piece of advice you have to your peers and colleagues listening in today?
I would recommend to plan really well, get really familiarized with all those technologies that seem to answer all the questions very quickly. You do need to do a deep dive and understand all the connectivity with folks you trust on their judgment, and they're not shy about telling you you're wrong. That's my advice.
Okay. I mean, admittedly, we have not had many conversations about VPP. So I have a feeling that we're going to get a lot of comments, questions, and follow-up. So I welcome everyone to post their questions on the Energy Essential podcast. I'm sure that, Vicken, when you get a chance, you'll keep the conversation going by engaging in some of those questions and respondents that people have. So once again, I want to thank you so much for sharing your insight on today's episode of the podcast.
My pleasure. Thank you for having me. Wish you all the best. Looking forward to it.
Absolutely. And you can always reach Vicken, as I mentioned, through the Energy Essential platform, where it welcomes your questions and comments. And we also want to give a shout out of thanks to the podcast sponsors that made today's episode possible. Thanks to West Monroe. West Monroe is a leading partner for the nation's largest electric, gas, and water utilities, working together to drive grid modernization, clean energy, and workforce transformation. West Monroe's comprehensive services are designed to support utilities in advancing their digital transformation, building resilient operations, securing federal funding, and providing regulatory advisory support. With a multidisciplinary team of experts, West Monroe offers a holistic approach that addresses the challenges of the grid today and provides innovative solutions for a sustainable future. And once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com, and we'll see you next time at the Energy Central Power Perspectives Podcast.